Hello. So Alex is out sick today, so I will actually be taking his place. And I'm going to introduce Connor Robinson. So first off, hi everybody. My name is Lauren Giannini. I'm one of the environmental health and safety specialists here at the Lonza Biologics Portsmouth site. It is my honor to introduce our sustainability fellow, Connor Robinson. Connor is currently entering his senior year at UNH, pursuing his bachelor's degree in environmental conservation and sustainability. Connor's propensity for knowledge and can-do attitude has helped him quickly adapt to Lonza's fast-paced atmosphere, and it has been a pleasure working with Connor this summer, and he has continued to impress the team with his dedication to improving the site's sustainability metrics. So Connor, I will pass it along to you.
Thank you, Lauren. I appreciate that a lot. So yeah, I'll get started here. So this summer I was working with Lonza Biologics, and the main thing I worked on was their 2030 sustainability roadmap. So in 2018, Lonza initiated a 2030 sustainability roadmap, which had a four-pronged sustainability metric system. So the 2030 sustainability roadmap hopes to see reductions in energy, water, waste, and CO2. And another big part of my job this summer was highlighting areas of achievement and looking at areas of improvement for sustainability here at Lonza. Next slide, please. So I've had the interesting experience of quantifying all of our projects that we're currently engaged in, and it's been very educational. And I want to say before I begin talking about this slide that not all of the projects we're engaged in have been quantified yet. We're about halfway through, so these numbers aren't complete. But so far in the year 2020, for CO2, we've estimated a reduction of 2,059 metric tons, and you can see a check mark right next to that. And that means that in 2021, we were able to reach that goal, and we're looking like we're going to reach our goal in 2022. For energy, we've an estimated 343,173 kilowatt hour reduction. The check mark there because we hit that goal and we're looking like we're going to hit it again. And for water, a 2.4 million gallon reduction this year in 2022. For waste, we were actually able to reduce 93,750 pounds this year, but I have a light bulb there because it doesn't look like we're going to hit our goal and we weren't able to in 2021. However, I have the light bulb there because I have hope that some of our long-term projects and new ideas are going to make us reach our goal before 2030. I know we can do it, and I'm excited to see how that plays out. For the next slide, please. So what are the next steps? So how are we going to reach these 2030 sustainability goals? Well, first, we need to continue quantifying our 2022 projects. Like I said, only about half are done. So all those reductions you saw on the previous slide, we're expecting to see larger numbers. We need to celebrate the achievements. We were able to hit goals in three areas, as the middle part of that shows, and I'm really glad we have been able to do that. Very large numbers. And even though we didn't hit our goal with waste, we've still been able to eliminate it from the site. So that's always good to see. And we need to continue brainstorming project ideas for our areas of improvement. And for all four of these sections, this project goes all the way out until the year 2030. So I'm looking forward to continuing brainstorming project ideas and seeing how Lonza is going to create more reductions. So what now is to keep up the great work and continue reducing our numbers. And for our area of improvement, we're currently engaged in a waste audit, trying to figure out exactly what areas need to be reduced and the areas that we can. We have a lot of processes in site that can't be changed, but we're still looking at waste that can be reduced. And we need to extrapolate our numbers from our long-term projects and just explore new ideas and try things out. It's always worth a shot. Thanks so much to Lonza. Special thanks for Lauren Giannini and Alex Gianluca for taking a shot on me. I'm not an engineering student, and this took a lot of engineering work. So, I really am very thankful that they gave me an opportunity to, try it out. Thank you very much.
Great, thanks so much, Connor, for a great presentation. So we've got a couple questions coming through on the chat here. So first, what methods did you use to quantify these reductions?
Yeah, so that is it's a really project by project process. So for example, if we're shutting down machinery, that's a pretty simple project because it's how much energy was it using, how much water was it using, how much CO2 was it using, et cetera. And now that it's shut down, we save that per year. But if we're upgrading a system or changing a process, that becomes a little more nuanced because we need to look at, how much water did the previous system use? Where did we eliminate it? Does this new system have hidden water that we don't know about? I think it's important to mention that these reductions are only estimates from some of the math and we did, and thinking about how the processes have changed. We won't really know the actual reductions until 2 or 3 years out when we see how the project plays out and how much those actual numbers are.
Great, thanks, Connor. And one more quick question for you. What kind of waste is the most challenging for Lonza to reduce? What type of waste stream?
That's a great question. And I think it's a two-part answer. One is expired materials. We over-ordered a lot because of COVID, because we are making active pharmaceutical ingredients. So we want a safety stock just in case things go wrong. So, but those tend to have different expiration dates. Or they tend to have quick expiration dates. So we've been trying to figure out processes to eliminate some of that expiration date problem, like changing the expiration date from Lonza's personal date to the manufacturer's recommended date to give us some more time. And the big problem is packaging is this huge. A lot of things that we have are extremely protected because they can't be altered or tampered with. So they're in a box, in a bag, in a bag, in a box. That's really difficult to eliminate. So we're trying to find other areas that we can change maybe.